Black Sheep Scarves will open several Black Sheep Scarves will open several new production facilities during the coming year. Each new production facility is designed to have one quality inspector who checks the knitting of the wool scarves before they are shipped to retailers. Obviously, now it's trying to describe you the situation that you want to simulate. Of course, they always need to provide you with enough details so you can do it. The arrival of hand-knit wool scarves to the quality inspection department is variable over the 24-hour workday. A concern is that during busy periods, the shipment of scarves to retailers may be delayed as they wait to be inspected. This concern prompted Black Sheep Scarves to undertake a study of the flow of scarves into the quality inspection department as a waiting line. Black Sheep Scarves Vice President wants to determine whether one quality inspector per facility will be sufficient. Black Sheep Scarves establish service guidelines stating that the average delay waiting for quality inspection should be no more than 1 minute. Let us show how a simulation model can be used to study the quality inspection for a particular production facility. Note that each scarf can be viewed as a customer in this example, since scarves are the flow unit passing through the system. One point that you immediately recognized here is that here it asks you for some sort of prescription. So it is prescriptive analytics, very similar to the previous one. Why it is prescriptive? Because it is giving you some guidelines to you decide about that. Here it says Black Sheep Scarves established service guidelines stating that the average delay waiting for quality inspection should be no more than 1 minute. So it is not asking you just simulate the waiting time of the scarves at the inspection station. No, it tells you calculate it, and after calculation, check if the average delay waiting time is smaller than or if it is not more than 1 minute. So if you noticed with one inspection station, there would be more than 1 minute delay time, so you should recommend for more than one inspection stations. So as you notice, the problem is not complicated, but since you have just started to do simulation, maybe now you have some problems how to start it. The steps that we are gonna follow together in the following slides and in the following of this video, in continuation of this video, will give you a good standard that how you should start simulation problem step by step. So when we read this, you may notice about some of the important things we have here. We have the arrival of the scarves, and also we have the inspection of the scarves, and we are going to work on that more. The first things that we need to know about problem is the most important parameters and variables that we have. In waiting line simulations, arrival times are determined by randomly generated the time between successive arrivals. referred to as the interval time. For the quality inspection department being studied, the scarf's inter-arrival times are assumed to be uniformly distributed between 0 and 5 minutes. Okay, here it is telling you about the arrival of scarves. And here you can find it. It says for the quality inspection department being studied, the one that we want, the scarf inter-arrival times are assumed to be uniformly distributed between 0 and 5 minutes. Since it is uniformly distributed and it is continuous, you don't need to learn another probability distribution. You already know, so you just need to work on the conceptual understanding of this page. So in the case, it says that that's random variables that you are working with is this one that you just got the description, the inter-arrival time, and it is uniformly distributed between 0 and 5. Okay, but I'm sure now you are wondering about this part that says in waiting line simulations, arrival times are determined by randomly generating the time between successive arrivals, referred to inter-arrival time. For example, now if I ask you, okay, now you know about this system, how you are gonna simulate the arrival of the customers, how you are gonna simulate arrival of the scarves. For example, you want to simulate the arrival of the first scarf. Okay, one. How you are gonna simulate it? You see, now when you think about it, okay, pause the video and think about this. That's how do you simulate the arrival of the first customers, arrival of the second customer? How do you say it? For example, the first customer comes at 8 a.m., the second one comes at 8:10, the next one came at 8, for example, 15. So you see, it continues until you get, for example, for example 30 p.m. It needs an idea to be able to simulate this, because so far the simulations that we have had about the part cost, it says that 43, 44, 45, 46, 47. For the demand, we had 15,000 and 4,500, the standard deviation, or we had the uniform one. Okay, how you are gonna do the simulation while it can continues forever? For example, in 24 hours, can you say that, for example, the first customer comes at 8:15 and the second one came at 4 and the third one comes at 12 p.m., for example? Of course you cannot, but it is the nature of random variables that if you want to generate random variables between 0 and 24 as the range of 24 hours, you may lose the order. So the way they do it is using this concept that now you are seeing in front of you, the concept of inter-arrival time. So they always assume the simulation start from time 0. And after that, the first customer comes according to the inter-arrival time that you generate. So the simulation starts from time 0. Okay, time 0. You generate the first random number. What is the first random number? A random number between 0 and 5 according to the things that you see. For example, assume you are generating 4. So 4, it means that the first customer comes to the store or a scarf, come to the inspection station at the time of 4. Now 4 as the beginning time, we go for the second customer. Generate a random number here. For example, you generate 2. So it is 2. So it says the second customer enters at the time of 6. What about the third customer? Generate another random number, for example 5. So it comes at the time of 11, and like this you continue. So my friends, you see here we have the difference between 6 and 4, that is 2, 11 and 6, that is 5, and like this we continue to generate the other random numbers. For example, if the next arrival happens at the time of 12, it means that the inter-arrival time has been 1. We continue to the next one, that is, for example, 14.5. So inter-arrival time has been 2.5, and like that you continue and do your simulation. So now if we go and review this slide together another time, you will understand it much better. And as you can see, it says in waiting line simulations, no matter it is customer, no matter it is scarves, no matter if they are cars, arrival times are determined by randomly generating the time between successive intervals. So we generate randomly these numbers. Let me circle them so you can see them. We generate 2, we generate 5, we generate, okay, we generate 12, we generate, oh, sorry. We generate 2.5. So when you have 2, you add it to 4. Also, we generate 4. So when you have 4, you get it by adding to 0, you get to 4. And when you have 2, you get to 6. When you have 5, you get to 11. When you have 1, you get to 12. And when you have 2.5, you get to 14.5. And that's it. That's the point here that you see between successive arrivals, referred to as the inter-arrival time. For the quality inspection department being studied, the scarves inter-arrival time are assumed to be uniformly distributed between 0 and 5 minutes. And the scarves, all the flow units here. If you still think you need to think more about this slide, just pause the video and think about it, and feel free to ask if you have any question. Here we go for another random variables that we need to use for this problem. It is a normal distribution variable. You know how to generate it when you have the mean. Here the mean is 2 and the standard deviation is 0.5 minutes. But when you look at the horizontal axis, it says service time in minutes. And with your brilliant smart mind, I'm sure you have discovered what it is gonna be. Because on one hand, we have arrival of scarves according to a model. Okay, and after that, we should have a model for the service time, because these scarves that are arriving needs to be served by the inspection station. They start being inspected. Another random variable in the black sheep scarf simulation model is service time, which is the time it takes a quality inspector to check a scarf. Past data from similar quality inspection departments indicate that a normal probability distribution with a mean of 2 minutes and a standard deviation of 0.5 minutes can be used to describe service time, that is inspection times. So on one hand, you generate those scarves random number that get to this inspection station, and when they get to the inspection inspection station, they are going to be served according to the mean of 2 and a standard deviation of 0.5. We are going to discuss the rest of this problem for next week.